Today we're going to start talking about identities again. We talked about some basic ones early on in this semester, but we're going to talk about two other sets of identities today. The Pythagorean identities and the odd and even identities. So an identity is an equation that is true for all values of the variable for which both sides of the equation are defined. So there has to be a value for each function that's in the equation, or that identity would not be true. Now, we talked about the cofunction identities early on. The one thing I'm asking you to do now is to express the complements in terms of radians rather than degrees. Initially, we learned them as 90 minus theta, but functions have to have the angles expressed in radians. So from this point forward, I'm going to ask you to write this in radians rather than in degrees. Then we learned about the reciprocal identities, because to find the cosecant of an angle or the secant or the cotangent, we had to type this into our calculator, or we wouldn't be able to find an answer. So you're familiar with both of these. We talked about the quotient or ratio identities just a wee bit, but we want to talk about them again because we need to have those in our brains. Tangent can be thought of as sine over cosine, and these are reciprocals of each other, so these fractions would be reciprocals of each other. And we'll be using these a great deal today. Now, I want to go back and talk about the notion of odd and even functions. If you remember, sine is odd, tangent is odd, and we talked about cotan being odd because we graphed these functions before we left, and we know that they have origin symmetry, so they are odd functions. Sine and cosecant are reciprocals, and reciprocals always are the same type of symmetry. Just like tan and cotan had origin symmetry, cosecant and sine will have origin symmetry. I want to talk about even functions for just a second, then we'll head back over there. If I have even functions of cosine and secant, because they are reciprocals, and you know we graphed cosine and we saw how it had that y symmetry, so it had to be a even function. I want to talk about what these statements mean and how we're going to use them. I'm just starting with that notion of having a 30-degree angle and a negative 30-degree angle. Now let's talk about cosine. If I'm talking about the cosine of 30, I'm going to get the square root of 3 over 2. And I wrote that wrong there. That should be the square root of 3 over 2. And the cosine of a negative 30, I wrote in red here, is a positive square root of 3 over 2 also, because remember, cosine is positive in the fourth quadrant. These two values are equal to each other. If you think about this as being your theta and your opposite of theta, they are equal to each other, and that is exactly what this identity is saying. One can replace the other. We usually want to talk about our angle theta in terms of theta, not the opposite of theta. So since they have the same value, one can replace the other. So if I had secant of the opposite of theta in an equation, I could just take that out and put secant theta in its place. Now if I'm talking about the odd functions, they are not equal to each other. Remember, opposite x's have opposite y's. So the sine of 30 isn't equal to the sine of negative 30, but it's equal to the opposite of it. So if I am trying to, let's say, I don't want to have but one angle in my problem. Some of my angles are theta, some of my angles are the opposite of theta. What I could do is when I replace sine of opposite of theta, I don't replace it with just plain old sine theta. I have to be replacing it with the opposite of sine, because opposite x's have to have opposite y values. Now, what we're going to talk about right now are the Pythagorean identities. And the Pythagorean identities are based on the Pythagorean theorem. I have an angle theta drawn inside the unit circle. We know that this distance here is 1. I'm going to go ahead and draw in that reference triangle just so it looks a little more like right triangle trigonometry to me. We know that this angle right here has a point on its terminal side called xy. That means I would go x distance along this axis and y distance up. Now I just had a right triangle, and according to the Pythagorean theorem, x squared plus y squared should equal 1 squared, because our r there is 1. So x squared plus y squared is equal to 1. But now that we're in trigonometry, we learned that x is really the cosine of theta, and we learned that y is really sine theta. Do you remember that? This number, whatever it is the cosine of this angle. This number is going to be the sine of that angle theta. So let's go over here and let's replace algebra with trigonometry. So that means cosine squared theta plus sine squared theta equals 1. Now, this is kind of a funky notation to you. Please pay attention. Instead of writing it like this, that's what we're trying to do. We're trying to square theta. Mathematicians are all about shorthand. So instead of having to put parentheses and then a square on the outside, they put their square on the cosine. But it means this, that whatever the numerical value of cosine is, we are going to square it. So we're going to square this cosine, we're going to square this sine, and this, of course, is the same angle. That is going to be equal to 1. That is the Pythagorean theorem. The cosine of an angle squared plus the sine of the same angle squared will always equal 1. Now I'm going to demonstrate that to you. Let's do the cosine of, let's say, 30 degrees. And we want to square that. And we're going to do the sine of 30 degrees squared, and that should equal 1. The cosine of 30 degrees is the square root of 3 over 2, and we'll square that. The sine is 1/2, and we'll square that. And let's see if that is equal to 1. When I square the square root, I get 3. When I square 2, I get 4. When I square 1, I get 4. 1, and when I square 2, I get 4. So 3/4 plus 1/4 is 1. And you can test it for any of the angles that you know, and this is always true. And this is something you've got to remember. Cosine squared plus sine squared equals 1. And it wouldn't matter if I inverted the order and I said sine squared plus cosine squared, because that's just commuting the order there, and that's okay. So I'm going to stop right there.